Hello everyone, welcome back to Advent of Code 2023. It's day 16 today, but as you can see I've already solved day 16. I intended to and tried to record a video, but made a mistake with recording software and I was muted through it, so very sad. I thought I'd at least put up a video today walking you through what I came up with and highlighting any interesting points that I spent a lot longer talking about during the the original solution. I'm not going to go through and read the whole problem statement out loud again. If you're watching this, you probably already know what day 16 was about anyway, and you can check it out yourself if you don't. So, we have to, do the whole ray tracing thing again, where we have, instead of pipes, we have mirrors, and stuff that goes through a mirror bounces, but stuff that goes through a splitter splits into two different rays. I decided to use an array, a two-dimensional array, indexed by coordinates, which we can see the coordinate is here. Very similar to what I did in some previous days. However, there were a few interesting things that I did with the types here that I thought would be worth going over. We have the same coordinate definition we've had before. Direction, I think, is pretty much the same. Feature, though, we'll get to some in a minute. Feature is different because I thought it would be kind of nice to... what is it you ever do with a mirror, right? If say you find a mirror, you're walking... Say you stored, you had a new type that was oh, it's empty, or a normal slash, or a backslash, or a pipe, or a minus. And maybe you even just use characters. And you, pattern match on that, and then you take a direction, and you, do some operation on the direction based on the character that you found. But that's really the only thing you ever do with features. You use them to decide how to adjust array. And so I thought, rather than saving a direction here and then having to write a pattern match on mirror for based on its four directions, based on the direction you approach the mirror from, do this other thing, I said, let's just do that all up front and have a mirror store a function from direction to direction. We'll compute that once when we do parsing, and then when we see a mirror, we'll call that function on it. Likewise, a splitter can store a direction and return a list of directions that you should go when you arrive at it. And if you arrive along the pointy end, the splitter is defined to just be the same as empty space, so it can return a list of one thing. And if you approach it orthogonally, it splits you into the two orthogonal directions. So a list, right? Well, this is another thing that I thought was kind of... The problem with a list is it lets you represent splitters that are not splitters, right? You could have a splitter that returns 5 directions, or no directions at all, or something, and that's not really a splitter. So I thought, rather than return a list and just assume it's always length 2, wouldn't it be nice to return a data type that is always exactly length 1 or 2? During my previous attempt to record the video, I recommended a blog post by Alexis King called, I think, Playing God with Static Types. Let me go look that up real quick again. I mean, you should read anything by Alexis King. She has a lot of very clever things to say. But 3 years ago, she put out a blog post called Types as Axioms, or Playing God with Static Types, about how to use the type system to help you devise data structures that encode the constraints your problem domain has, rather than letting those be implicit, where if you use a list, it's implicit that it has exactly 1 or 2 elements or something. Here, you easily have the power to define a list, or a data type, that has 1 or 2 elements exactly. And it's not very difficult to work with this because it participates in all these type classes that that lists do. You can treat it very much like a list, but you get all these nice guarantees. And in fact, in this solution, I use functor and foldable on some. I don't think I end up using traverse. No, I don't. But you can derive traversable, and it seems like a good idea. But I guess you could get rid of it. Whoops. Come back. Okay, traversable. So a feature is, you know, a mirror, or an empty or a mirror or a splitter. We could even go a little bit further if we wanted and say that a feature isn't a data structure at all. It's just a function from direction to some direction, where like empty is the function that just like says keep going straight. A mirror is a function that happens to always return exactly 1, and a splitter is a function that happens to return 1 or 2. You know, I think that would be fine, but it's also kind of nice to have like splitters be a separate thing. I don't know. So I thought that was kind of cool. Trace is the type for like a ray. I probably should have called it array, but I had called it ray trace before, and this time I picked the wrong half of the word. It's a location and a direction, and we're going to be chasing those through the grid. As usual, I'm defining like what is the unit vector for a direction. And next is a function that takes a feature and a direction and decides what direction to go in next. And we pattern match on empty, and it's just which directions to go in next, because we have some, right? So it's pretty simple. We just call the function and wrap it in 1 if it's a mirror. If it's a splitter, we just call the function, which already returns a sum. So I don't know. I mean, I think this is kind of nice. Very simple translation layer, whatever. It's obviously not necessary, but I think it's cute. Here's where we walk one step from a single trace to one or two traces, given an input, which is, I guess, here? I ended up moving this later, so an input is just an array mapped by coordinates of features. So you step given a grid and a trace. You call nexts on the feature that you find at the current position and pass it D. That gives you back some directions. And then we fmap into that. So for getting back a sum of new things based on the sum of directions we got. Which is just, we just return a trace adding the original coordinate to the unit of the direction we're supposed to go in, and the direction we're supposed to go in is the direction we found in the call to nexts. Step all, I thought we would want a way to, we'd be tracking multiple traces, and we want to step all of them by 1. And that way we have like a single state, which is, you know, the grid with a bunch of traces in it that represent the active beams we're tracking down. So we just call like, this is all like implicit, right? The list of trace argument is implied. We just pass it in here. First to bind, we call step G, and then we call toList. This is us using the foldable instance for some to treat it as a list. We keep only those ones that are actually inside the array's bounds. That's one reason I chose to use an array rather than a map from coordinate to feature, is that we get bounds checking for free if we use an array. It's basically the only reason. We keep those that are in bound, and we uniqueify them. Nub_ord is a way to, you know, take a list and uniqueify it somewhat more efficiently than nub. because it's kind of silly if we happen to have multiple traces that are all doing exactly the same thing at the same time. We might as well throw one of them out. And then I wrote this function run till repeat that takes a function from A to A and an A and gives you a list of all the things until it repeats. And so we have a set of seen states that we've seen, and if we get to a state we've seen, then it's done running. Otherwise, we add the current state to the list and keep going after adding the current state to the scene list. Pretty simple stuff. We've written this before, I think. And part one is, what do we end up doing? Yes, we start with a list of just one trace, and we step all of the traces through G until that repeats, and we fold map the list of currently active, why do they call it actives? Oh, all the traces that we've ever, the coordinates of all the traces we've ever seen. So each iteration of step all is going to return a list of all the traces that are active. So we'll turn that into a set inside of actives. Set.fromList map coord. Actually, it would have been better to just leave traces implicit here, but it's fine. And then we ask, what is the size of that set? What is the size of the set of all coordinates that have ever been part of an active trace at any time? That's how many cells were ever energized by a trace starting here. And there's this parser here, which is a little different from, I mean, I don't know. It's an applicative regex parser, just like we've done in most days before. But it turns a string into an array. An input is some lines, a line is some features, a feature is one of these three things. Empty is pretty simple. Mirror is... This is one thing I also wanted to talk about, is I got kind of tired of writing the... the pattern match of, the four... You have to write like the cross product kind of your four directions by the 5 features you can have, really, right? Empty, or the 2 mirrors, or the 2 splitters, right? I didn't really want to write 20 things, 20 cases in my patterns. So I thought some more about how these mirrors behave, and it occurred to me that if you think about the enum, the index each of these has, right? North is enum 0, east is 1, south is 2, and west is 3. And if you think about these as binary numbers, 0, 0, 0, 1, 1, 0, and 1, 1, then, for example, the mirror like this, say you hit this mirror from the west, you're going east, and you go north. The result of that is that you had flipped the bottom bit of the enum here, right? And if you were approaching the mirror going north, i.e. coming from the bottom, you bounce off of it going east, again, flipping the bottom bit. And the same thing holds for south and west. And the other kind of mirror is a similar story, except you flip both bits. So I decided, where's my parser, to just have this symbol be the binary number 1 as an argument to this reflect function, a mask. And this symbol be the binary number 3, 1, 1. And so to reflect takes a mask and just converts the direction it's given from enum into an int, XORs with the mask, and turns it back into an enum. And I did something sort of similar here using the enum representation, noticing that north is right in between west and east, and east is right in between north and south, and so on in the order here. So to split, is to just go from where you are to both one before and one after it in the sequence. So splitter, I did have to guard it and say like, oh, okay, you know, if it's, because the splitter doesn't always split you. If you arrive at it in the pointy end, it just tells you to keep going straight. So I basically say, okay, a splitter is guarded by directions. You know, this splitter goes east to west, and if the direction you're currently in is one of those directions, then just like return the original direction. But if you're coming at it from one of the other directions, then return two results, going +1 and going -1, and then this go function just like does the to enum from enum dance. So that's it. And yes, I have no uncommitted changes. And I forget. I think this took a while to run. 10 seconds, maybe? Is my recollection? A bit longer here because I had to run build. I had some earlier versions that took even longer, like one that took several minutes while I was, you know, thinking of a different approach. I let it run for, I don't know, 10 minutes or something before it came back with the answer. But it works. And then we get to part 2, of course, where it says, okay, great. Now find the entry point for the beam that maximizes the number of cells that it ever energizes. And, you know, the grid is 110 by 110. So I did a little math and I said, 10,000 times 10 seconds is 100,000 seconds. I'm pretty sure that's too slow. And that's like a week or something, or I don't know exactly. I calculated it at the time, but 100,000 seconds in days is, oh, it's a day. Sure. So it would have taken about a day to run if you were to just brute force it this way. But that is obviously not what we want to do. So what I did instead, actually, let's look at the git diff here. So here's my delta for part 2. I guess there's an easier git command to get that, but whatever. Basically, I said energized by is a function from input. Basically, part 1, I pulled out and put it into its own function that part 1 and part 2 can both use. But I improved it by tracking, instead of like until the entire state of the machine repeats, I said, let's prune it as we go. Anytime we're asked to watch a trace at a coordinate and direction that we've already tracked a trace for at that exact coordinate and location, it's obviously going to do the same thing and light up some cells that are already lit, so we can throw it away. And so in this case, the scene list is a list of traces we've seen, rather than a list of like entire states of the whole grid that we've seen. And then like there's not that much interesting happening here, I think. We say go starting with an empty set, and that filters the traces that it's being given, T's, to those that are not already in the scene set. If there are no such, it just returns the scene set saying, here's all the traces I ever saw. And if there are any, then we just recurse into Go by adding all the traces that we have into the scene set. And we step all those traces by one step and pass that as the other argument to Go. Then in part 1, outside here, once we get the scene set, we look at only the coordinates with s.map, and ask for the size. What is the size of the set of coordinates that were ever seen by this recursive algorithm? And then in part 2, we just do the obvious thing of, there we go, scroll down like this. I just make 4 lists of all the ways you could possibly fire a trace into the grid. Going in each of the directions from each of the edges, or the corresponding direction from each edge. Concat the results into one single list of all the traces you could start with. Then call energized by for each of them and find the largest result returned. Not that complicated. Just had to make sure to write a more efficient way to prune the search space with energized by. And I can show one more thing is just like I did some cleanups. I don't know. There's not really much to look at here. I just moved stuff around, deleted white space. Got rid of the call to nubord in step all because the energized by function is already trimming things it's seen before. And also got rid of run till repeat because I wasn't using it anymore in that once I had energized by, I wasn't ever running an entire process till it repeats. So, I mean, there you go. Sorry you didn't get to see the solution evolve in real time as usual. Like I said, I tried, but I messed it up. That's life. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.